Okay, so in this video, we will be tackling how to print a binary tree. So for that, let us call a particular class. Okay, in this, let us call a print tree as a function. Now, before this, there is a particular tree class, which is a tree node, and there is an initializer self comma val comma left comma right. Okay, self dot val is equals to val, self dot left is equals to left, self right is equals to right. And there will be default values which will be passed: val equal to 0, left equal to none, and right is equal to none. Okay, now when we come back to this print tree function, so let us first remember that we are passing self dot root into this. Okay, the root element is passed as a input. Okay, now if that particular root is none, we want to basically return the value of none, right? Then we basically want to iteratively print our tree. For that, we need to know basically the height, the number of columns, the number of rows that we want to print. Here we will have the value of height will be equal to maximum uh, depth of the tree that we have found. So basically that minus 1. So this is basically the height of the tree. The root will also include the maximum depth. The root also will include the root of the tree, and height does not include. So height is equals to maximum of depth of the root minus 1. In that case, call calls will be equal to pow, which is basically power 2 power of height plus 1 and minus 1. So this is basically the call. Now the result array, it basically contains basically contains first the string values for iter in calls, range of calls, or whatever the numbers, and such array within an array should exist for range of height plus 1. Okay, so this is basically, and then iteratively we are going to call what will be the contents. So for that, we are going to once this is found out, we want to return the resultant array. But before that, we need to understand that we are going to do depth first search, wherein we will be passing first the root value, and then iteratively we'll be calling node by node. And initially we will be passing the row as 0 and the columns as calls minus 1 by 2. So here we will be creating another function which is called as DFS function in order to perform the depth first search, and here we will be passing node, row and column. And now we will be writing this particular function. Here there is also one user defined function which is called as def of maximum depth of a particular node, right? Now we are basically calling these two functions. Now, if you think about it, if node is none, so this is a boundary condition, then return 0 as the maximum depth. Else, in other case, we are going to find out left depth, which will be basically equals to maximum of depth of node dot left, and there will be right depth, which will be basically equals to maximum of depth of node dot right. Okay, now in any case, if left depth is greater than right depth, in that case we are going to return left depth plus 1 as the maximum depth of the tree, and else we will be returning something which is called as right depth plus 1. Okay, now instead of writing this as if and else, we can also write, okay, uh, we are basically returning depth including node is equals to maximum of left depth comma right depth plus 1. So this is what we are trying to, and then we will be returning the depth which is including this particular node. Now this will be passed as the maximum depth. Okay, so maximum depth minus 1, then columns will be equals to power of 2 power of height plus 1 minus 1. Then we are arranging this resultant array. Now finally in this we are going to introduce this depth first search function, which says if node is none. Okay, then you just need to return. Okay, otherwise we are going to basically rest of call will be equals to string of node dot val, because we are introducing it as in the form of string. Then we are going to basically call this function in recursion. Okay, so it will be node dot left, then row plus 1, and then it will be call minus power of 2 comma height minus row minus 1. In the same way, the formula for this node dot right comma row minus 1, this will be equals to call plus power of 2 comma height minus row minus 1. So in this way we finish this particular statement also. Okay, uh, let us copy and paste this in lead code, and let us submit this. Okay, so it turned out to be wrong. So here there is a mistake. So this one needs to be row plus 1. Okay, once this is done, and if I copy this and I test this again on, if I submit this again, it gets accepted. So this is basically the program for printing of the tree. what it does is we first check for the boundary condition, that is if root is none, we then return none, and we basically find out the depth of the tree, the height of the tree, because based on that we need to output the values like this. When if root is 1 2, then we have to arrange this in this way, in that the height will be equals to whatever the depth including the node minus 1, and the columns will be 2 power of height plus 1 minus 1. So it is written in Python mathematically like this, and the resultant array will have the number of columns is equal to this, and we need to write it in terms of the string, and the number of rows will be equals to height plus 1. So these are the things that you need to remember. Now we need to calculate using functions two things. One of them is finding out the height of the tree, and the other thing is we need to traverse using depth first search. Now in the depth first search, first we are throwing root, then we are throwing the row value and the columns value, and the columns value will be equals to cols minus 1 divided by 2. Okay, and now we need to pass it to the depth first search. If node is none, we are returning, then rest of row and column is equals to string of node comma value, and then node dot left row plus 1 column minus a power of 2, that is column 2 power of height minus row minus 1, and the other one is 2 plus column plus 2 power of height minus row minus 1. So these are the depth first search. Now for the maximum depth, if node is none, return 0. Left the depth is equals to max depth of node dot left, max depth of node dot right. Depth including node equals to maximum of left depth, right depth plus 1, and we basically return depth including node. So this is how we are doing printing of the binary tree. Thank you for watching the video.